Lesson 13.1, Task 2. Define a mathematical series. There are many times that it is useful to know the sum of the terms in a sequence. A series is the expression formed by adding the terms of a sequence. For example, 5 plus 10 plus 15 plus 20 plus 25 is the series formed by adding the terms of the sequence 5, 10, 15, 20, and 25. The series above has a finite number of addends, 5 to be specific, and so is a finite series. An infinite series expresses the sum of the terms in a finite sequence, and so has infinitely many addends. To represent a series effectively, you can use sigma notation, named for the Greek letter for S, which is represented by this symbol. Okay, so this symbol here is sigma notation. All right, so it says, for example, the terms of the sequence above can be expressed by the rule 5 times n, where n is between 1 and 5. Sigma notation uses the index of the summation using the letter k or another letter to count for the terms from the lower limit of the sum to the upper limit of the sum. All right, so it shows you here. This is the sigma notation, and it goes from the lower limit to the upper limit. So k equals 1 to 5, and the rule, or the equation, is 5 times k. So that means the summation of this series here, you would do 5 times 1 plus 5 times 2 plus 5 times 3 plus 5 times 4 plus 5 times 5, and that would equal 5 plus 10, 15 plus 20 plus 25. So if you did that, that's what it would do here. And I can show you there is a button on your calculator, which is nice to know, especially if you're in a hurry. So you have math, and if you scroll up on the math button, if you have a new TI-84, it should have a summation button, and all you have to fill it in. So if you want to find the sum of this series from 1 to 5, just put in a variable. It says k or another variable. We use x the most often, so I just use x because the variable doesn't matter. And then I'm going to go from 1 to 5, and I want to evaluate 5k. And since we used x, we'll use x here again. All right, so if we do that, the sum of those numbers is 75, okay? All right, so it says, note that the changing the upper limit to n gives the series which represents the sum of the first n multiples of 5. Changing the upper limit to infinity gives the series which represents the infinity series, 5 plus 10 plus 15 plus the dot, dot, dot. The dot, dot, dot means it continues, and that's what we have to use when there's an infinity sign there. All right, so it says, recall from task 1 this sequence, a of n equals 11 plus 3 times n minus 1. So this was the number of seats in a theater, and this represents the number of seats in n rows of a theater. All right, so for the series, k equals 1 to 14. So 11 plus 3 times k minus 1. This is our rule or our equation. So match each value with what it represents in the context of the theater seating. All right, so we've got k, 1, 14, and then the equation. So the first row added in the sum of seats, the first row would be the 1. All right, the last row would be 14. The index is just the letter that we're using in the summation, and the total number of seats should come from the equation. All right. What is the sum of the series? Okay, well, let's use a calculator to find out how many seats are in that theater. So again, go to math, arrow up to 0, that's your summation. And I'm going to type in from 1 to 14 this time. So x, 1, and then 14. You do have to arrow up to get to the top. and then I'm going to put in 11. I'm going to put it in exactly how I see it, plus 3 times, and since I used x, I have to use x, but everything else is the same, and then minus 1, and I'm going to close that parentheses, and then hit enter. So there are 427 total seats in the theater. Now you can do this by hand. You could add up the individual terms from plugging in 1 to 14, but I don't see why we do that if you have a calculator that will work. All right, so for a special show, the first 6 rows of the theater contain this many seats, and they're reserved for season subscribers. Find the sum of the series. All right, so once again, we'll go to math. Sum. This time we're going to sum from 1 to 6. And then we're going to do 11 plus 3 times x minus 1. And this gives us the number of seats in the first 6 rows. So in the first 6 rows, there are 111 seats. All right. What do you notice? All right, so we already found the sum of this. And what do I notice? Well, the first 6 rows has 111 seats, so that means rows 7 through 14 have the remainder of the seats. Does this make sense? Yeah, sure it does. We could find the number of rows if we needed to. Let's do math, sum, and let's do x. Let's do from 7 to 14. That's the remainder of the rows. And then the first 6 and the remainder should add up to be the total number of seats. So we're going to do 11 plus 3, same formula or same equation. All right, and you can see that 316 and 111 give you 427, and 427 is the number of seats that we found before. So yes, it does make sense. All right, that's all for task 2. If you have any questions, let me know. Lesson 13.1, task 3. Create and use rules for sequences. Because sequences are functions whose domain is a subset of integers, you can simply substitute domain values to create a sequence from a rule. Consider the sequence a of n equals n squared plus n with a domain of 1, 2, 3, 4. Substitute 1, 2, 3, 4 into this to find your answer. So you're going to have 1 squared plus 1, 2 squared plus 2, 3 squared plus 3, and 4 squared plus 4. So you can see we substituted the domain n for n and just found those numbers. So the range would be 2, 6, 12, and 20. So the first 4 terms are those numbers, and often you will look for a pattern to write a rule for the sequence. All right, so it says consider the sequence negative 12, negative 6, negative 4, negative 3, negative 2.4. All right, so it says creating a table can help reveal a pattern. So you can see there's not a common difference and there's not a common ratio. So let's look at something else. So if we do negative 12 divided by 2, you get negative 6. Negative 12 divided by 3 is negative 4. Negative 12 divided by 4 is negative 3. And negative 12 divided by 5 is negative 2.4. Okay, so the rule is your inverse variation. Okay, so it says from the table it's easy to see that the sequence represents an inverse variation relationship. The rule can be written as a of n equals negative 12 divided by n, or a subscript n equals negative 12 over n. All right, so it says the practice ranges of professional golfers often stack the balls in a pyramid as shown. Write a rule for the sequence that represents the number of balls in each row of the front triangle face of the pyramid. Then write a rule for the sequence that gives the total number of balls in each layer and graph the sequence. All right, so if you look at this here, you can see that on top there's 1, and then there's 2 by 2, so there should be 4 in the second row. And then there's 3 by 3, so that's 9. And then there's 4 by 4, which is 16. Okay? So it says from the top down, the number of balls on the front face is the sequence 1 through 7. So I guess they're going 1, 2, 3, 4, 5, 6, 7. So there's 7 layers there. So starting at the top, n equals 1. So a rule for the sequence is simply a of n equals n. Or say a subscript n equals n. To write a sequence representing the number of balls in each layer, start at the top again with n equals 1. Write an ordered pair for the sequence. So the top layer had 1 ball, the second layer had 4, the third layer had 9, and the fourth row had 16. So we've already kind of looked at that. This one had 4, the third one had 9, the fourth one had 16. So they're just writing those as ordered pairs. So it says, how did you determine the number of balls in each layer? Well, we just looked at it, and since it's a side view, you can just see how many balls are in each layer. All right, so it says the number of balls in each layer is the square of the layer number. So the rule for the sequence is a of n equals n squared. So if we graph these ordered pairs, the graph is going to look exponential, like exponential growth. Or not exponential. We know what it is. It's n squared, so it's quadratic. It is a quadratic in nature. It does look a little bit like exponential too, but the variable would have to be an exponent if it was exponential. All right, so it says, what is the rule of the nth term of the sequence written in subscript form? Okay, remember it's the same. It's just this should be a subscript instead. So instead of a of n, it should be a subscript n equals n squared. And that's all for task 3. If you have any questions, let me know.